Hello, grade 10 learners. Today is another opportunity for you in learning mathematics. I am Sir Christopher Tibocio A. Berdidas here in National High School, and I'm here to guide you in today's lesson. Are you ready? So bring out your pen and your mojo. Together, let's explore the concept of illustrating polynomial function. Hi graded learners. Today we'll be discussing on how to illustrate polynomial functions. In this lesson, you are expected to determine what is a polynomial. But first, we need to learn some definition of terms. The first one is polynomial expressions. Polynomial expressions is an expression consisting of variables and coefficients that involves only the operation of addition, subtraction, multiplication, and non-negative exponent of variables. Like for example, x raised to the third power of x cubed minus 2x plus 5. First, we need to identify what is a variable. So the variable here is the x, and the coefficients are 1, negative 2, 5. And the operations are subtraction and addition. Next term, we have polynomial function. A polynomial function is a function denoted by p of x is a sub n, x raised to n plus a sub n minus 1, x raised to n minus 1, plus a sub n minus 2, x raised to n minus 2, plus infinity, plus a plus 1, x plus a sub 0, where n is a non-negative integer. A sub 0, a sub 1, a sub n are real numbers called coefficients, but a sub n is not equal to 0. A sub n, x sub n is the leading term, and a sub n is the leading coefficient, and a sub 0 is what we call the constant term. So, the non-negative integer. The non-negative integers are 0, 1 half, 1, 2, 3, 4, 5, and so on and so forth. Make sure that the integer is not negative. Coefficients. Coefficients are the a sub 0, a sub 1, a sub n. But take note of this, that a sub n should not be equal to 0. The leading term. The leading term here is the a sub n x raised to n. And the constant term here is a sub 0. Next, polynomial in standard form. So a polynomial in standard form, it is any polynomial whose terms are arranged in decreasing powers of x. So take note, decreasing power of x, depleting. For example, 5x cubed plus x squared minus 7x minus 3. As you have observed that the power of x is decreasing from 3, 2, and 1. My dear students, are you ready? Now, let's check it out by answering the following question. Question number 1. Which of the following expression is a polynomial expression? Is it A, B, C, or D? I will give you 10 seconds to guess the answer. Have you got the answer? Let's check it out. If your answer is letter A, then that's correct. How about number 2? The following are examples of polynomial expression except. Is it A, B, C, Again, I will give you 10 seconds. Have you get the correct answer? Let's check it out. If your answer is C, and that is correct. Let's proceed to question number 3. What is the standard form of the polynomial function f of x equals to 3 minus 7x plus 2x cubed? I will give you 10 seconds. Have you get the correct answer? If your answer is letter A, and that is correct. How about question number 4? The standard form of the polynomial function y is x times the quantity of x plus 5 and x minus 5 is? I will give you 10 seconds. Is it A, B, C, or D? Have you get the correct answer? If your answer is letter A, and that is correct. Okay, question number 5. What is the factored form of f of x is x cubed minus 3x minus 2? I will give you 10 seconds to answer. Is it A, B, C, or D? Have you got the correct answer? If your answer is letter A, and that is correct.
Okay, now let's determine a polynomial expression. A polynomial expression is an expression consisting of variables, coefficients, that involves only the operations of addition, subtraction, multiplication, and non-negative exponent of variables. Here are the 5 examples of a polynomial expressions. Number 1, x cubed minus 2x plus 5. Number 2, 5x cubed plus x squared plus 7x minus 3. Number 3, negative 10x minus 2x squared. Number 4, 2x minus 10. Number 5, 1 minus 32x squared. What are the ways to determine polynomial expressions? To determine a polynomial expressions, see to it that an expression can be written in the form of a sub n x raised sub n plus a sub n minus 1 x raised sub n minus 1 plus a sub n minus 2 x raised sub n minus 2 plus so on and so forth plus a sub 1 plus x a sub 1x plus a sub 0, wherein is a non-negative integer. Next things we do is the expression of a sub n x n plus a sub n minus 1 x raised sub n minus 1 plus a sub n minus 2 x raised sub n minus 2 plus so on and so forth plus a sub 1 x plus a sub 0 are what we call the terms. And the number a sub n, a sub n minus 1, so on and so forth, a sub n, a sub 2, a sub 1 x, and a sub 0 are what we call the coefficient of the polynomial. The term containing the highest power of x is called the leading coefficients. Remember that the highest power of x is what we call the leading coefficient. And the power of x contained in the leading term is called the degree of the polynomial.
Okay, let's try this, my dear students. Now, You will determine whether each of the following is a polynomial expression or not by putting the star. So, I will give you 10 seconds to answer. We have number 1, 7x. Number 2, 3x squared minus 4 square root of 2x plus x. Number 3, 3 over 2x plus 1 over x. 3x squared minus 3 over 4x 5. 4, 2x squared plus 3x plus 1. 5, 1 over x squared plus 2x raised to negative 2 over 3 plus 7. Have you got the correct answer? Let's check it out. Now, my dear students, let's check your answer. Number 1. Is it polynomial or not polynomial? Polynomial. Number 2. Not polynomial. Why? Is it because a polynomial should not have variable inside the radical sign? As you observe that negative 4 is square root of 2x. Inside the radical sign, there is a variable x, so it is not considered as a polynomial. Number 3. Not polynomial also. Why? Is it because a polynomial should not have variables in the denominator? As you observe that in the denominator, there is a variable. For 3 over 2x, there is x. 1 over x squared, there is x. And also 3 over 4x5, x, there is always a variable. Then it's considered not polynomial. Number 4, yes, it is a polynomial. And number 5, it is not a polynomial, my dear students, because a polynomial shouldn't have fractional or negative exponents. As you have observed here that in number 5, 2x raised to negative 2, which is a negative exponent, over 3, which is a fraction and negative exponent. If you observe it is considered not polynomial. I hope you got it right, my dear students. Now, let's proceed to how will you be able to determine a polynomial functions. First, we need to define what is a polynomial function. So, a polynomial function of degree n is a function of the form of p of x. A sub n x of n plus a sub n minus 1, x raised of n minus 1 plus a sub n minus 2, x of n minus 2 plus so on and so forth plus a sub 1, x plus a sub 0, where n is a non-negative integer in a sub n minus 1, a sub n minus 2, so on, a sub 0 are real numbers and a sub n should not be equal to 0. How do you determine a polynomial functions? So other than p of x, a polynomial function may be also denoted of p of f of x rather. So you can write, instead of writing p of x, you can write it as p of f of x rather. Sometimes a polynomial function is represented by a set of ordered pairs, which is the x and y, which is the abscissa and the ordinate. Thus, a polynomial can be written in different ways like the following. As you observe that p of x, in the first one, you can write p of x is a sub n, so on and so forth. And we observe in the second one, we have dy representing the ordered pairs. So a sub n, x raised to n, plus a sub n minus 1, so on and so forth. Okay, here are the 5 examples of polynomial functions.